When winter arrives, electric vehicle owners all ask the same question. Why is my range suddenly disappearing? You start the car, you turn on the heater, and within minutes you watch your estimated range drop faster than your battery percentage. And then someone says, "Don't worry, you have a heat pump. It saves range." But does it really? Today we're breaking down one of the biggest myths in the EV world: heat pump versus PTC heater. Which one actually saves more range? And more importantly, when? Because the answer is not as simple as most people think. Let's start with the basics. In an electric vehicle, there are generally two ways to heat the cabin. The first one is a PTC heater. PTC stands for positive temperature coefficient. But forget the fancy name. Think of it like an electric space heater in your living room. Electricity goes in, heat comes out. Simple, instant, predictable. For every 1 kilowatt of electricity you use, you get 1 kilowatt of heat. Efficiency ratio, 1:1. Now let's talk about the heat pump. A heat pump doesn't create heat directly. It moves heat. It extracts thermal energy from outside air and transfers it inside the cabin. In ideal conditions, 1 kilowatt of electricity can move 3, 4, sometimes even 5 kilowatts of heat. That sounds unbeatable. So case closed, right? Heat pump wins? Not so fast, because physics has something to say about that. Let's imagine two scenarios. Scenario 1, it's plus 15 degrees outside, mild weather. The outside air still contains plenty of usable thermal energy. In this situation, the heat pump works beautifully. It extracts heat easily. The battery is already close to its optimal temperature. The system doesn't struggle. Within 5 to 10 minutes, the heat pump becomes far more efficient than a PTC heater. Over a 30-minute drive, it can use dramatically less energy. In this scenario, yes, the heat pump clearly saves range. Now scenario 2, it's minus 10 degrees Celsius. You just started your car. The cabin is freezing. The battery is cold. The coolant is cold. The metal pipes are cold. And here's the part most people don't talk about. Before a heat pump can heat you, it has to heat itself. This is called thermal inertia. Every physical system resists temperature change. Your battery pack, coolant fluid, aluminum housing, heat exchangers, they all have mass, and mass requires energy to warm up. In extreme cold, the heat pump must first warm up coolant, stabilize refrigerant pressure, heat internal components, bring the battery closer to its operating window. During this time, it consumes energy, but delivers very little cabin heat. Meanwhile, the PTC heater, instant hot air, no delay, no ramp up, no complexity. For short trips under 10 minutes in very cold weather, the PTC heater can actually feel more effective, and sometimes even be more energy efficient in that short window. That surprises most people. Now here's where things get interesting. After about 15 minutes of driving, something changes. Your motor starts generating heat. Your inverter produces heat. Your battery produces heat. This is where waste heat recovery comes in. Modern EVs with heat pumps can capture this waste heat and redirect it into the cabin. Now the system doesn't need to fight freezing outside air as aggressively. At this stage, the heat pump begins to dominate. Over longer winter drives, 30 minutes or more, the efficiency advantage becomes real. This is why people report completely different experiences. Someone who drives 5 minutes to the grocery store says, "Heat pump doesn't help at all." Someone who commutes 40 minutes daily says, "It saves me tons of range." Both are right. Context matters. Let's talk numbers. A PTC heater always has a coefficient of performance of 1. 1 unit of energy gives you 1 unit of heat. A heat pump can range from 5.0 in ideal conditions down to 1.0 or even below during extreme cold startup. And that swing changes everything. At -25 degrees Celsius, extracting heat from outside air becomes extremely difficult. The compressor works harder. Efficiency drops. The advantage shrinks dramatically. That's why some manufacturers use hybrid systems. They start with PTC heating for fast comfort, then gradually transition to heat pump operation once the system stabilizes. It's not about which system is better, it's about when each one is better. Now let's answer the big question. Which one saves more range? Here's the honest answer. Heat pump saves more range on medium to long drives in mild to moderately cold weather. PTC can be equally effective, or even better in very short, extremely cold trips. The real enemy isn't the heater type, it's thermal inertia and trip duration. Your winter range is influenced by outside temperature, drive length, battery starting temperature, preconditioning habits, thermal management design. Not just heat pump versus PTC. Now let me give you 3 practical tips that can preserve serious range in winter. First, preheat while plugged in. Let the grid handle the energy required to overcome thermal inertia, not your battery. Second, use seat and steering wheel heaters on short trips. Heating people directly requires far less energy than heating the entire air volume of the cabin. Third, if you have a garage, use it. Starting at plus 10 degrees Celsius instead of minus 10 degrees dramatically reduces heating load. That difference alone can preserve significant range. Here's the takeaway. Fast heating consumes energy. Efficient heating takes time. A heat pump is not magic, it's physics. And physics rewards longer, stable conditions, not short, freezing bursts. So next time someone says, heat pump always saves range, you'll know the real answer. It depends. On time, on temperature, on thermal inertia. And that's what separates marketing claims from engineering reality. If you enjoy deep technical breakdowns like this, where we go beyond surface-level explanations, let me know in the comments. These videos take days of research. Your likes, subscriptions, and watch time are what make them possible. And if there's a specific EV technology you'd like me to analyze next, tell me below. Because in the world of electric vehicles, the real story is always deeper than it looks.